Hey everyone, it's Mrs. Slauson, one of the Algebra 2 teachers, and this is ICANN number 1, first attempt for second semester. So in our first problem, we will be working with this particular polynomial function. And the first thing we're going to do is describe the end behavior. And we know its end behavior just by looking at the leading term. And the fact that we have an even exponent says we're going to kind of have some type of U shape. And the fact that the number is in front is a positive number says our U will look very much traditional. It will not be flipped. So with that, what we could do is quickly draw in our arrows. So arrow to the right is infinity, infinity. Arrow on the left is negative infinity, infinity. And from there, I can do my end behavior. So the first one's been done for you, if you notice. The second one, we still need to write out. So I'm going to do that. And in both cases, whether x is getting smaller or bigger, in the end, our y values are getting bigger. So for both of these, I will be putting infinity, infinity. Our next question is how many solutions are there? And that is also going to be the job of that exponent. It is telling me that I'm going to have 4 solutions. And now what we're going to do is we're going to find those solutions. We, in problem 1c, call it finding the zeros, which just means I basically take my function and I set it equal to 0. So 0 equaling this. And it does say, don't forget to look for a GCF, and hopefully you'll notice as I'm rewriting this that a GCF that I could factor out of everything is a 2 and an x. So I'm going to go ahead and take that 2x out. I'm going to put it way over there. And then what I have left is x cubed plus 4x squared minus x minus 4. And what I'm going to do now is factor what's still in parentheses. And since there are 4 terms, we're using this new method called the grouping method. So I group my first 2 and my last 2. And in my first set of parentheses, I will be looking for another GCF, which happens to be x squared. So when I take that x squared out, or factor it out, I'm still left with x plus 4. And when I factor or look for a GCF on my second set of parentheses, I want you to remember that these will have to be identical. I call them the twins. And that means I have to take out a very specific GCF. So to get x plus 4 as a GCF from the second set of parentheses, I would have to factor out a negative 1. And so what happens now is my 2x can come along for my factors. My GCFs become one of my pairs of factors, and my x plus 4 is the other. And if you do notice, that would be great if you did, that x squared can factor further into x plus 1 and x minus 1 because it is a difference of squares. That's even better. And now all I have to do is set each factor equal to 0. Set 2x equal to 0. I get a solution of 0. Set x plus 1 equal to 0. I get a solution of negative 1. And I can just continue that with all my factors until I get my 4 solutions. On 1D, we are to use the graphing calculator. So going to the graphing calculator, I will be going to the y equals button. I will be typing in my equation. So let me highlight it in just a different color. And then I will be pressing the window button and entering in this window. Now, normally when we do this, I want us to find all of the important points, but just kind of reading ahead, and I want to keep this video short, I do notice that I only have to find the negative interval and the average rate of change. So I won't be finding all the key points due to that. But anyway, going to the y equals button, turning it on, maybe. There's my equation already typed in. I have pressing the window button. There's my window, and now I'm going to hit graph. And there is my shape. So I'm going to take that shape and I'm going to draw a really rough sketch of it over on the right. And now I'm going to mark my important points. So we've already done the arrows, but here they are again. And then our job is to find the zeros. So I'm going to remind you how you find the zeros for one of them, and then point something out so I really don't have to find the zeros for all of them. So what I do for that is going back, I press second trace. I want to find the zeros, the x-intercepts, and somewhere on here is my cursor. I'm going to have to hit my left arrow to bring it back down into view. There it is. And let's say I want to find, I want to find the one I'm getting closer to. So the first thing I do is I get my cursor close to where I think that x-intercept is, that 0. And once I get my cursor there, for left bound, I hit the arrow a couple of times to the left, 2 or 3 times. Once I do that, I hit enter, and then I go back to where I think that x-intercept is, which is there. And then for right bound, I hit the right arrow a couple times, enter, and then for it to guess, I hit enter one more time, and I've got my 0. So I'm going to go ahead and write that down, 1, 0. And what I want you to realize is all I'm doing is writing these x-intercepts right over there, because I already found them, the zeros. So looking at that, that means this one's going to have to be -4, 0. This will have to be -1, 0. And that one would be my 0, 0. Go ahead and put those in parentheses. And now I can find my negative intervals. So the opposite of negative is positive. And so this first stretch is one of my negative intervals, but then I have another stretch over here. So I'm going to write them both down. So -4 to -1 and 0 to 1. The next part, average rate of change, AROC, you do need to remember that these are not x and y, that these are both x's. So if x is -2, what's y? And if x is 2, what is y? And so to do that, I can go back to the graphing calculator, hit second trace, choose option number 1 for value, and then just type in your 2 different numbers that you need. You need -2, which results in -24. Repeat that, second trace. Choose option 1 again, put in 2, and that will give me 72. So I'm going to write those numbers down. And now I'm going to go to my formula. It tells me all about the table. So here's my table. In the bottom, I put my sturdy legs, which are the x's. So I'll just do -2, subtract 2. And then in my y's, I'll have to subtract -24, take away 72. And so when I do that, I'm going to get -96. And then once I divide those 2 numbers, I get my average rate of change. So 24/1. All right, let's move on to the next problem. In our next function, the CP that you see in front just means it's going to be capstone problem. And a capstone question, instead of end behavior with that LIM notation, uses the wording of rising and falling. So based on my leading term, I know that this is going to be some type of line because of the odd exponent, and it's still going to be a positive line going uphill because of the +2 in front. So that means it is falling on the left over here, and then it's rising on the right side. So I'll choose this option. How many solutions are there? Again, that's my exponent. I've got 3. What's the y-intercept? Y-intercepts are just when x is 0. So if you did put 0 into these first 3 terms, each term would basically turn into 0, because when you take 0 to a power, you get 0. And when you multiply with 0, you still get 0. So the only thing that would be left in that equation would be the -16. So here is my y-intercept. Let's go ahead and find our solution. Again, we want to look for a GCF. I do not see one here, but I'm going to rewrite my equation. And because there are 4 terms, I'm going to group them again. And in my first set, I will GCF out an x squared, which leaves me with 2x plus 1. So for my twin over here, I need another 2x plus 1, which means I need to take out a very specific GCF. That would be a -16. So remember, factors come in pairs. My GCF is 1. What's my twins, let me write that there, is the other. And if you happen to notice again that this is a difference of squares, it turns into x plus 4, x minus 4. Now I can take each factor, set it equal to 0, and solve for x. So my 3 solutions will be -4, 4, and in the far right one, I would subtract my 1 and then divide by 2 to get -1/2. All right, let's go ahead and finish this up. Flipping the page over, we are just solving. So on question number 3, we're going to solve with our problem. Again, don't forget to look for a GCF. I do not see one. So I'm going to make my x, and the top part is going to be -56. If you put those x's in there, great. I will this time. My middle term is going to be my bottom, and I would need factors of 56 that make 1. That would be an 8 and a 7, with the 7 being negative. And now I can go ahead and make my parentheses. And remember, when you are factoring, this first term and this first term, when they multiply, have to make this. So traditionally we've been putting x and x, but that doesn't make x to the 4th. It makes x squared. So if I just turn these into x squared, because those do have to match, now I get my x to the 4th. And if I draw my face, I call it the face, then with this invisible 1 times what? 1x squared times what could make this? And that would be a +8. And with an invisible 1 there, 1x squared times what could make this? And that's a -7. And now I can take each factor, set it equal to 0, and get my solutions. So remember, we are going to have 4 solutions in this problem. So when I take the one on the left and I add 7, and then I square root, this little 2 again is about to tell me I'm going to get 2 answers, and just whatever the square root of 7 happens to be. And on this one, I would subtract 8, and now when I square root, again, I'll get 2 answers, but I'll be taking the square root of a negative number, so I'll be getting an I, and then whatever the square root of 8 is. We do want to start working in second semester, if you didn't do it much in first semester, is even though 8 is not perfect, it has factors that are. And what I can do is take the square root of 4, which is 2, bring along the I, that is not in the check mark, and then bring the square root of 2. So that is actually the best answer and one that we will be looking for in semester 2. All right, last problem. We're going to find the zeros. Again, I want to look for a GCF, and this time when looking at my problem, I do notice I can factor out a 2 and an x, so here it goes all the way over here. What's left is this. Oh, no, I take that back. I cannot take a 2 out, so never mind. Let's just go not a 2, but I can take an x out, so not paying attention. All right, here we go. And looking at this problem, I'm realizing there's a little typo here. That 2 should actually be a 3. You will have the correct version of that, so let me fix that real quick. And making my x, I'm going to need factors of, 90, that are going to make -23. And 90 has a lot of factors. So the two that we will be using are 5 and 18, and they will both have to be negative. So bringing along my GCF, now working on this, here come my factors, which come in pairs. And remember, x and x will not be enough to make this 2x to the 4th. So first I'm going to have to give them both x squareds, put a 2 with one of them, and now I get 2x to the 4th. And now when I make my face, oops, I didn't even make the x. I apologize on this. Let me pause for a moment. All right, so I'll have to ask myself, 2 times what can make one of these numbers, and that will make the -18. So I'll put a -9, because 2x squared with -9 makes the -18x squared. And maybe you like that invisible 1 times a -5 makes the -5x squared. And I'm going to set each factor equal to 0 to get my 5 solutions. So this one's done. For this one, I decided to not do the difference of squares, just to show you that you don't need to. I'm going to add the 9, and I will get 2 answers. When I take the square root of 9, I get plus and minus 3. And this one, I'm going to have to write real fast because I'm about to run out of time. Here we go. Plus or minus the square root of 5/2. And I've got my 5 answers.